Hi, I'm Barry Taylor. About 4 years ago, I was working as an architect in Virginia, and our firm was doing things the old-fashioned way. We were drawing and designing by hand, the way we'd been taught in school. But then we were approached by Microtexture, a new company which was developing a product called DataCAD, a PC-based CAD product for architects, engineers, and construction professionals. We were a little skeptical about it at first because none of us had used CAD before, none of us had used computers. But after only 2 weeks of using DataCAD, we were producing working drawings, doing design changes, even looking at 3D renderings. And we weren't the only ones who were impressed. At a national CAD shootout, DataCAD was the product of choice, and it was chosen by the American Institute of Architects as the product that it decided to sell in 1985. Well, since then, things have changed. Microtexture is now an internationally recognized software development company. DataCAD is marketed in several countries worldwide, as well as here in the United States. And there have been over 2,500 DataCAD installations to date. Let me tell you a little bit about the products that we'll be looking at today. First of all, there's DataCAD, our computer-aided design and drafting system. It's unique because it has an integral 3D database, which means you can look and design in all sorts of 3D views and have all your views simultaneously updated. Then we'll go on and look at DataCAD AEC, a series of parametric design routines which can automatically produce office buildings in under 15 minutes. We'll go on and look at the DC Modeler, our 3D solids modeling program that allows you to take up to 15 different primitive shapes and make solid models that can be hidden and rendered. And finally, we'll look at Velocity, our photorealistic 3D rendering package, which includes such sophisticated features as surface shading, translucency, and a rendering in 256 colors out of a palette of 16 million colors. So let's get started. To show you DataCAD, I'd like to work on a small residence that I've drawn prior to the demonstration here. What we'll do is go in and add a study in the lower right-hand corner of the living room. But before we do that, let me tell you about a few DataCAD concepts you'll want to keep in mind. First of all, DataCAD is easy to use because it's menu-driven. That means there are no commands to memorize. All you do is point and click at features on the left side of the screen. If you want to reuse something you've drawn before, you can make use of DataCAD's template menu. For example, here, I'll call up on the right-hand side of the screen chairs. There are hundreds of these symbols included with the DataCAD program. They all come up on the screen, and they're very easy to use. We'll take a look at them a little bit later on. Finally, DataCAD includes a very sophisticated interrupt structure. And what I mean by that is that if I were to decide to move in on this section of the drawing and then draw a line or two, as I draw that line, I could interrupt what I'm doing with a whole series of other operations. For example, changing the angle of the line, perhaps changing the line color, or even the line weight. So here I've ended up with a thick red line, and before I finish this next line, I'll change back to white, go back to a thinner line, and turn that orthogonal grid back on. This interrupt structure allows DataCAD to operate a lot more like a designer thinks, which is that you go 2 steps forward, change your mind, go 1 step back, and then go on to something else without losing your place. But I don't want to show you how to draw lines as much as I want to show you how to put buildings together. So let's focus on a particular menu in DataCAD which is included with the program called Architect. In the Architect menu, I can draw walls, put in doors and windows, just with the press of a button. Let's draw the study walls. First, I'll turn on the walls. I'll come out to the point where I want to start the wall, and we'll extend the first wall to the left, locating the other side of the wall as we go, and notice that DataCAD clips out the new wall to the existing location. Then I can come down to where the wall is going to stop, locate the other side, and DataCAD will automatically clean out the wall. These are the walls for the study, but now let's go back and change the wall width to 4 inches instead of 8 inches, which is what we had before, and put in some closets. I'll locate the 2 walls of the closets like this. Notice that they also clean out to the existing walls. I'll line this first closet up with the second one, interrupting with a large cursor. And once I have the closets, then from the same menu I chose the walls, I'll choose door swing. Door swing will allow me to locate two sides of a door, let's say here and there. Tell DataCAD which way the door swings, in this case in, and DataCAD will cut the wall and place the door in automatically. And if we zoom in and take a look at that door, you'll see that it's a door complete with a sliding hinge and jambs, thickness of the door, and so on. In much the way we did the single door, we can go on and do other types of doors. For example, I'll choose bifold, and we'll put a bifold door down into this closet wall, again just by choosing the two sides of the door and locating the hinge direction. Or a sliding door, which I could locate in this wall, like that. So here in just a few short moves, I've designed the entire study and put some closets in for the rest of the house. Now from the same menu, I'll choose Windows. And Windows will allow me to put in, dynamically, windows in the outside wall just by showing DataCAD where the two sides of the window are. Notice that I can size the windows dynamically as I go, making ones longer or shorter depending on my preference at the moment. I don't have to use pre-sized windows. Once I have the doors and windows drawn, then I can go about editing my drawing. And if you're a designer, you know that 90% of your work is editing, and that's where DataCAD's stretch menu really comes in handy. For example, I can take this wall, stretch it down to the right just by putting a box around it like this. Or I might decide to change my mind and invert that wall and at the same time move the window down, all in one operation. As I do that, the walls are automatically healed, so that if I should decide to invert the window and put it back, I can handle just the window, and again the walls will heal up behind me. This makes DataCAD a great design tool as well as a great drafting tool. What about other productive features? It's great to be able to redesign, but what about when you get into working drawings, you've got a lot of dimensions on the drawing and then you want to change the design? Well, DataCAD can handle that too. Let's zoom in on this top wall. First, we'll dimension it using DataCAD's automatic dimensioning function. All I do is locate the 2 points on the wall, the left point, the right point, and an offset. And DataCAD puts in an entire string of dimensions, even including overall dimensions, if I want to see those. Not only that, but if I were to zoom in on this particular section here with a sliding glass door, I can see that I've got a 9'2" dimension going from the center of that door to the right-hand wall. Well, what if I were to change the design? I could go back and stretch the door, let's say 1'6" to the left, and when I put a box around the door, the dimensions will automatically update. This is called associative dimensioning. Because that dimensioning is associative, I can even change basic settings in the program, like what units I'm drawing in. I've been drawing in architectural units, which are feet and inches, but I might change over to metric units if my project were being built overseas or perhaps in Canada. And then just by the touch of a button I could see my building now dimensioned in meters. So I can design in one coordinate system and dimension in another. And now I'll go back to architectural units. So far I've been showing you how to draw new lines and new parts of buildings very quickly. But the real powerful part of any CAD program, including DataCAD, is the ability to reuse what you've drawn before. And that's where DataCAD's template functions really come in handy. As I showed you a moment ago, DataCAD's templates appear on the screen on the right, as you see here. I don't have to take my eyes off the screen to look at a tablet menu. And as I said, there are hundreds of symbols included with the program, yet these symbols are customizable by the user. And they're easy to use. All I have to do is come over to where the symbol is, hit a button, pull it out into the drawing, and as I pull it out, I can optionally spin the symbol to any orientation, which I'll do with each of these 4 chairs, spinning them to different locations in the drawing. Now as I do this, if I wonder what these chairs are, I simply move my cursor into the template window, and down on the green line I see that this is a swivel chair by Herman Miller. Here we have a Vienna chair by Thonet, a Breuer chair by Stendig, a Wassily chair by Stendig. Again, DataCAD provides help all along the way. Let's pull out two more of these chairs. Spin this one around like that. And spin the last chair around to an orientation like this. Well, up till now we've been doing some 2D drafting. But what about if we wanted to look at our building in 3 dimensions to see how the design really looks? DataCAD has already been building that in as we've been going along. In fact, everything we've drawn has had default 3-dimensional heights. What that means is that if I were to go over to DataCAD's 3D viewing menu and to call up a perspective, I could see immediately the room that I've just designed with the windows in it and the 4 chairs that I just inserted. And as you can see, those chairs are correct in a 3-point perspective just as they're correct in plan. Not only that, but these chairs and all other symbols are not just graphic, but they can be data-based, which means that we can go quickly back to the template menu, even while in 3-point perspective, and generate a report about this furniture. Once I have the report, we could come back to graphics mode and do other editing functions on the symbols. For example, we could say, let's replace this chair with another one of the Breuer chairs. And even in this 3-point perspective, the editing change is made live on the screen. And if I go back to my plan, now I have 2 Breuer chairs in plan. This is a really good way to see DataCAD's interrupt structure at work. To give you another example of that, I might decide that I want to take one of these chairs and move it. Let's take the Breuer chair here and move it incrementally forward like that. But to see how the change really makes the room look, I'll interrupt that move command by going back to my perspective, which has been remembered. There are my 4 chairs again. And now I'll execute the move command just by choosing the chair that I want to move. And so we can now see the chair reposition itself in 3-point perspective coming forward towards me, thus becoming larger. And I can repeat that operation as many times as I want. Again, all changes here will be made back in plan. So now we see where the chair really is in the room. We've seen how DataCAD can help you design and draw small buildings like residences, and how you can redesign those buildings quickly and efficiently. But what about larger buildings where you have hundreds and thousands of lines, a building like a large commercial office building? Well, DataCAD AEC has been designed specifically to deal with that kind of structure. Instead of allowing you to just draw lines and then repeat those lines like columns or doors or windows or whatever parts of the building you're dealing with, DataCAD AEC starts with the actual parts of a building, columns, doors, elevators, windows, stairs, and puts them together in varying combinations that you decide upon. The result is a program that can help you design a small office building in less than 15 minutes, where the same building might take over an hour in DataCAD and over 3 hours manually. Let's take a look at how DataCAD could draw such a building, starting from scratch. DataCAD AEC has been created to be a designer's tool from the ground up. When I load DataCAD AEC, what comes up on the screen is a menu that follows the process that I use to put together an office building. For example, first I put in a drawing sheet so I know where I'm working. Then I lay out the column grid of the building. I do walls, windows, and doors. I put in the core of the building with elevators and stairs. I label the building using room labels. I might analyze the building in square footage calculations and then furnish the building with furniture and go on to my other disciplines such as plumbing, mechanical, and electrical. All of this is laid out in one very simple menu. As we go through DataCAD AEC, you'll notice that at every point help is available. All I have to do to ask for help about columns, for example, is point to the columns, and I get a one-line hint as to what that menu does. If I need more help, I can immediately jump to a text screen and get exact instructions on how to make column grids using this program. Once I know the instructions, then I can take a look at all the options that are available in that particular menu with the options described and how to use them. Help is available for me any step throughout the program. But now what I'd like to do is actually sit down and draw a small office building live. Let's start out, go into a drawing sheet menu, and locate the drawing sheet here. DataCAD AEC automatically puts a drawing sheet on the screen for me, including title blocks and detail blocks, which are completely customizable. I'll get rid of the detail blocks for this demonstration, and then I'll zoom in a little further to create the column grid. In order to make that column grid, all I have to do is go to a columns menu right below drawing sheet and decide that I want to do, in this case, a rectangular grid of columns. Well, how many columns are there? Let's say there are 6 across, 5 down, and that the spacing between the columns is 16 feet. I might say that the column itself is a 12-inch by 12-inch square column. With just that little amount of information, I can locate a point on the screen, and DataCAD AEC will take over and construct the entire column grid, including not only the columns, but also the grid lines and the grid symbols, and put them on 3 different layers for me automatically. So that if I zoom in here on the upper left-hand corner of my drawing, I can take a look there at column A1, automatically labeled for me. Once I have the column grid in, then I can go in and put in the exterior wall of the building. To do that, I go back to the DataCAD AEC menu, to the next menu down, and choose Walls. Here I'll set a wall width of 1 foot, and we'll create the wall by making a rectangle around the outside of this column, and what you're seeing here is DataCAD's automatic save function saving the drawing as I go. So in the event of a power loss, all my work is saved. There's the wall that we've created. And now we'll go back and put in windows in that wall by choosing the menu right below Walls, Windows. DataCAD AEC allows me to create linear bays of windows or circular bays of windows. Here I'll choose linear bays of windows, and just by specifying that I want 20 windows across this facade, equally spaced, I locate 2 points and the outside of the wall, and DataCAD AEC automatically breaks that wall, inserts mullions, and inserts the windows glass automatically. Let's zoom in on that. All that work done for me just with a couple of presses of the button. Glass thickness, mullions, sills, all are customizable by me, the user. I could go on and create windows for the other 3 facades of the building, and that would really give me the exterior skin of the building. Now let's go in and take care of the building core. To do that, I'll zoom in on one particular bay, one column bay inside the building, where I want to create an elevator and some stairs. To create the elevator, I'll just go to the elevator menu on DataCAD AEC, where I see up at the top selections for the number of cabs and the capacity of each elevator. Let's say we have 2 cabs in this building, and the capacity of each elevator is 2,000 pounds. That's all I have to do. DataCAD can dimension the elevator based on that information, so that all I need to do is locate where the front of the elevator is, which direction it faces, and DataCAD will produce the 2 elevators, the cabs, the doors automatically, and all those pieces and parts are customizable by the user. We'll back out of the elevator menu for a moment, change our wall width to 8 inches, and create a couple of extra walls so that we have a cavity within which to fit the stairway. And once I have this set, we'll go to the menu right below Elevator called Stairs, which allows us to produce 3 kinds of stairs: stairs that go up and down, stairs that go up only with a section break, and stairs that go down only with no section break between the stairs. For our purposes, we'll use up and down stairs, and I can create those stairs just by setting up the number of risers, the stair width, and the treads, and then locating where those stairs start, let's say here, and which direction they face. And DataCAD AEC will take over and construct all the parts of the stair, the risers, the treads, the railings, even the section breaks between the up and down stair. so that I could zoom in on this and take a look at even the hand railings automatically drawn for me and the nosings which overhang the risers. Once I've got this part of the core in, I'll jump over to another section of the building. Now, I'm pretty fast at this, but I'm not quite this fast. Obviously, these are walls that I drew prior to starting the demo, and I drew another stairway here just like the one you just saw me draw. I've set up two rooms, which I'm going to make a men's room and a women's room, and now I want to insert plumbing fixtures into these bathrooms. This again can be a time-consuming process in most CAD systems, but with DataCAD AEC, I simply go to a plumbing menu, locate where I would like fixtures to start, let's say here, where I want them to end, let's say there, which side of the wall they're going to face, and then up pops a menu of all the basic types of fixtures that I would use in a men's room. For example, handicap stalls, urinals, and sinks. And down on the message line below, I can see that I have one handicap stall, 2 stalls, no urinals, and 3 sinks set for this room. Now, this is a men's room, so I want to increase the number of urinals by 1, and I'll decrease the number of stalls. That leaves me with 2 inches left on the wall. And so I'll ask DataCAD AEC to automatically space out their sinks in that 2 inches, and then begin to draw automatically the toilet partitions and all the fixtures for that bathroom. And these can be symbols that the user can customize, so you don't have to use our fixtures, you can make your own. Once I've got the men's room, then the women's room is easy. Instead of having to redraw the whole thing and reconstruct the whole women's room, I can just go back to the plumbing menu and locate where that line of fixtures starts and stops, and then simply take out the urinal and put the stall back in and tell DataCAD AEC to begin again. And so here we see a different arrangement of like fixtures but different spacing because the stalls are wider than the urinals. That really takes care of the core, and so now we can go out to an overall view of the building and take a look at what we've been drawing so far. Here I see the exterior wall and the core that we've just put in. I've gone over to a layer where I want to do some square footage analysis of this building. Real estate developers, landowners, facilities managers need not only to put in graphics quickly, but they need to be able to analyze the buildings that they've drawn to determine how efficient they are for rentability to tenants. How efficient is this building if I have one tenant on the floor or if I have multiple tenants on the floor? How do I know how much space each part of the building takes up? And what happens if I increase or decrease some of those spaces? How does that affect the overall rentability of the building? Well, another menu in DataCAD AEC called Square Footage Calculations takes care of that for me. When I go to Square Footage Calculations, DataCAD AEC will count up all of the zones in the building which I have defined. And here I've predefined a zone called Floor 2. And in Floor 2, which blinks there, I've predefined several spaces: the stair, the electrical closet, the women's room, the lobby, the elevator, and the second stair, so that I can find out information about any one of these spaces, such as its square footage. I can also go in and create new spaces within this zone, which I'll do here to give you an idea of how this works. I'll choose Add Space, and I'll say that I want to add a space called the men's room. Immediately, DataCAD asks me, what type of space is this? Non-rentable space, building common space, rentable, or floor common space? Well, it turns out that the toilets are rentable to the tenants, and so I define this as rentable space, and then zoom in and trace the area that will make up the men's room. This will then allow me to extract information about the area of that room into a report. So if I were to do this with several rooms in the building, as I've pre-done here, we could then generate reports which I could send out to a printer or which I could pull in from text files and locate anywhere on the drawing or save out to disk. And what we'll see when I zoom in here is that in the first report, we've generated some information about this zone that we called Floor 2. We know its gross building area, 5,200 square feet, how much the non-rentable services like the elevators take up, how much the other services like the electrical closet and the stairs and so on take up. I can pan across this drawing until I take a look here at the actual usable tenant area, 4,500 square feet, left in the building, and the single tenant factor, which is a relative number telling me how efficient this building is compared to other buildings that would be rented to single tenants per floor. In the same way, I could pan over to the far right of this report and look at the multiple tenant usable area. What if we had more than one tenant on a floor and they had to share a corridor, and what my efficiency factor is for multiple tenants. And then in the second report down below here, I can break down the building according to the different types of space and look at the square footages occupied by each type of space. This gives me a really good way of understanding what a building is likely to cost me in terms of rent, or what income I can expect from a building over several years. Once we've built a building core like this, we could go on and add in interior walls. Now again, I haven't drawn these walls quite that fast. I've drawn them before the demo, but I drew them in the same way that you saw me draw the walls for the core, the building core. And so if I had a partition plan like that, I might go on to specialized work like plumbing work or electrical work, possibly mechanical work, and put in information related to those disciplines. Here, for example, I'll zoom in on one particular area of the drawing and go down to DataCAD AEC again, this time choosing the electric menu and the ceiling grid option. Here I can create reflected ceiling grids simply by putting in boundaries. Let's give this grid a little different color so we can see it better. I'll create a boundary for the grid like this. Within that boundary, I'll place a ceiling grid of a certain size, let's say 2 feet by 2 feet, just by locating, and we'll make that yellow, just by locating where that grid starts. And once the ceiling grid is in, I can go on and create fixtures such as a 3-foot round fixture, which when I insert it will automatically break the grid, allowing for the placement of the lighting fixture in the ceiling grid. Now these fixtures could be the ones that we supply with the program, but they could also be fixtures that you create yourself. There, for example, is a more traditional 2x4 fluorescent fixture. And so what you've seen me do here in a very short amount of time is to create an entire office building using these automated routines in DataCAD AEC. And what we haven't yet seen is that many of these routines are three-dimensional, which means that if I were to go over to a parallel view of this, I could see the building in isometric. I could even go in and look at the building in perspective and see toilet elevations and ceiling grids at the ceiling level and things like that. So even though this is a production tool, you do have three-dimensional capability that fits in with the other parts of the microtexture product family. This really is where we can begin to talk about an interface between production and modeling. The next part of the microtexture product list that I'd like to talk about is DC Modeler, which is our three-dimensional solids modeling program using up to 15 different primitives to create solid models that can be rendered. So let's take a look at that now. There are several drafting programs on the market that allow you to do 2D drafting. And there are other programs on the market that allow you to do 3D solid modeling, that give you the ability to do renderings. But there's really no other program that can handle 3D solid models and 2D drafting in the same database, the same drawing, even on the same layers, and work interactively between all the 2D and all the 3D views, consistently and constantly updating all your information back and forth. DC Modeler, coupled with DataCAD, does that. DC Modeler is based on 15 primitive 3D shapes, which can be manipulated by you, edited in any view, to create complex solid models that can be rendered with programs like Velocity. Let's take a look at a way in which we can use DC Modeler on the building we've just drawn. I left off drawing this commercial office building in DataCAD AEC and produced an isometric view of it. But this is really just a projection of 2D drawing up into 3D. It's not really a solid model. However, we could go over to a Layers menu and turn on some pieces of a building that I've drawn prior to the demo, which are built out of solid 3D geometry. Pieces like the exterior windows on a facade, perhaps the floors on what might be a balcony, the outer wall of the balcony, square columns along the exterior, or maybe I'll turn those square columns off, the entablature up on top of a porch, the railings along a porch. All these parts could be parts of a 3D model blended with a 2D production drawing behind the facade, so that I can create in one drawing a single model for all my design on a project. Let's focus now specifically on the 3D modeling that DC Modeler allows you to do. Here's a view of just the parts of the model that I've built prior to the demonstration. Here's an elevation of the same model. And now what we'd like to do, to give you an idea of how I constructed this, is to go into this facade and add some round columns that go from the first floor up to the third floor with bases and capitals on the columns, and then repeat those columns across this facade to do a study of how this building ought to look. To do this, I'll zoom in on where I want the columns to start. Let's say right there. And then I'll use DC Modeler going over to a 3D Entity menu to create the column out of a surface of revolution. Here's how this works. All I have to do to create this column with a base and capital is define the perimeter of the column. And so I stretch out a base like this. Then I move up the column, zooming back midstream to my previous view without losing my place, as you can see. Jump up to the top of the column, again without losing my place, and come down from the top of the column some increment so that I can easily put in the capital of the column like this. Trace over to the center line of the column, and then just by locating that center, the DC Modeler will automatically create round columns based on that perimeter. Well, creating the column is the hard part. Once I've got the column on the screen, I can quickly create other columns to make a whole facade of columns. All I have to do is go to the Copy menu, tell DataCAD I want to copy 8 feet to the left, and then select the column that I want to copy. Or I could say, let's create a whole array of those columns 8 feet to the right. And here I'll have 8 columns across and 1 column down. Select the entity, and I end up with a whole facade of these round columns. And because DataCAD's system is interactive, not only are these columns positioned in the elevation, but I can go back to other views, like a perspective, and see the model that I had drawn prior to the demo with the addition now of the new columns in the order that I drew them. So here we see the construction of a model facade which could be rendered, and later on in Velocity we'll see this model rendered in 256 different colors. For now, though, let's just imagine what would happen if we took DC Modeler's ability and extended it a little bit. We might have created our office building as part of a larger scheme, a site plan of several streets. Perhaps out in front of our facade on the right, we would have created a courtyard shown there in magenta and put some items in the courtyard. Then, using all 3D modeling parts, we could have looked at an overall site plan. Here's the building that we created using DataCAD AEC. Here's a site plan of several streets and other buildings, the facade that we created out front, and a courtyard filled with a fountain and a three-dimensional car, and in a couple of moments here, 2 three-dimensional trees, all built with the modeler, all capable of being not only hidden, but also rendered. So here we'll see the second tree go in, and then a second facade, and then finally the columns that we drew just a moment ago. DataCAD's viewing ability is not limited to these kind of exterior perspectives. I could actually stand down inside the courtyard and let the building grow toward me. So here I see the fountain, the car with its three-dimensional tires and chassis coming in, and now the trees in the foreground. One tree there and one tree in the background. And finally the columns that we drew last of all. These kind of renderings can be produced with DC Modeler without using any actual rendering package at all. But if I want to produce photorealistic renderings, that's when I'd want to use Velocity. Velocity allows me to render these models in up to 256 different colors from a palette of 16 million different colors, and provides many sophisticated features not found in other rendering packages. Let's take a look at Velocity and what it's capable of. If you're like most designers, you've always wanted to produce high-quality renderings for your clients, but have often been prevented from doing so by the high cost and the time it takes to produce such renderings. Well, now Velocity can change all that. Velocity is more than just a shading program. It's a 3D rendering program that can take the models you create in DataCAD and DC Modeler and shade them in up to 256 different colors out of a palette of 16 million colors. Velocity also includes a lot more. It includes smooth shading of curves. It includes up to 17 different simultaneous light sources so that you can light your object the way it really appears. It includes translucency, so you can create smoked glass, tinted glass, or even translucent, transparent glass. It includes surface mapping of textures and materials onto the surfaces. It even includes output to screen or to slides, so you can create a slideshow directly from the computer. And Velocity is fast. Each rendering that you'll see takes only about 4 to 8 minutes to create. What I'd like to do is show you the Velocity interface, and then we'll take a look at a slideshow to give you an idea of some of the kinds of images you can create using Velocity. Like other microtexture products, the Velocity interface is easy. It's menu-driven. All you have to do is select a rendering file. That would be a DataCAD drawing file. And then select attributes for that file. Now, by attributes, I mean, what do you want to do with all the lines in the drawing? Do you want to make the blue lines marble? Do you want to make them wood? Well, first of all, you need to decide on colors. And so Velocity will allow you to take a look at a color palette, which we'll see here. The palette gives me help in selecting my colors, and then I can use this menu that we're looking at to select surfaces such as a matte surface, perhaps a glossy surface, metallic, steel, copper, tin, aluminum, nickel, brick, wood, marble, even stone, to map onto a particular portion of my model. I can even set opacity or translucency for the model. So I might decide that these blue lines are going to be 50% opaque surfaces. We might be able to see through blue plastic, for example. Once I have this all set up, then I can go down to View Specification. And for every view that I've saved in DataCAD, I can select to render that view and send the output to either a slide or the screen. I can also specify lights around the object. Up to 17 different lights, either bright or dim, in any combination that I choose. And once I've got all that set, I would come down and begin the rendering process, which would take about 4 to 8 minutes. Now, to speed up that process for this demonstration, so we can see a lot of slides, I'll show you some examples of images that we've created previously with Velocity. Here, for example, is a rendering of the facade that we produced using the DC modeler, here with square columns. We could take a look at the same facade, but this time substitute round columns, such as the ones we drew, and here you can see the smooth shading around the round columns. Or we might go back to the square columns and add in a background. When I did the DataCAD demo, I inserted some chairs from a template into the drawing. And here's one of those chairs, the Wassily chair, which was actually a 3D solid object alongside a lamp, which is also a DataCAD template, and I've drawn a half-high wall behind them. Then I created a series of views flying around the object, and we'll just take a look at those views now, batch processed in Velocity. This batch processing allows me to create fly-through models, fully rendered, with such features as translucency, as you see there on the lamp, and as I come down into this chair, you'll begin to see differences between the fabric of the chair, the smooth matte surface of the fabric, and the highlights on the chrome of the chair, especially on the corners of the chair. This kind of smooth highlighting is extremely sophisticated, and very few rendering programs can handle this. We'll keep zooming up on the chair until we approach the fabric on the rail, go right through onto the seat of the chair, and then look back up toward the light through the fabric of the chair. And then finally an overall view, this time with a different floor material. Other buildings, Le Corbusier's Villa Savoie, for example, rendered here with a translucent green facade. Or in this case, rendered with translucent facades and a background supplied with Velocity, a cloud background that makes the building appear to float in space. Velocity isn't limited to rendering just architectural objects. This car, for example, took me only about an hour to produce in the DC modeler, and then about 8 minutes to render in Velocity. You could also design other industrial objects like Coke bottles, which are as simple to produce as the column that I made while I was in the DC modeler. These images give you an idea of the quality of the Velocity product. The products I've shown you today are a demonstration of Microtexture's commitment to you, our users, a demonstration of our commitment to the AEC industry, to professionals like you who count on us to provide them with solutions that are easy to use yet sophisticated, both now and for the future. We're standing by with products and services that will help you compete in this industry. We're looking forward to being your design partner for the future.